Hi, Melody. So there's a lot to unpack in this question that you've given me, largely because I don't know what you know and what you don't know already. What this is saying, this question is saying it wants to find the area that's shaded under the area of a normative curve from a z-score of negative 1.75 to a z-score of negative 1.02. Now, here's the part that I don't know. I'm assuming you know by now that in a normal curve, they're saying that the mean, the median, and the mode is 0 of the z-score, that the standard deviation is 1, so that if I got down to here, this would be a z-score of 3, and this would be a z-score of about negative 3, and that's what a typical z-score looks like. Now, what you also need to have then is you need to have the ability. Now, unfortunately, I'm not able to change my pen colors. It doesn't look like on this thing at present. Maybe there it is. So what it allows us to do is go negative 1.75. Well, negative 1.75 is about here, more or less. And where it exactly is isn't really important, as long as you have a rough guess. And then negative 1.02, again, not exact, but is probably somewhere around here. So what we're looking for is the area under the curve that is greater than negative 1.75, but less than negative 1.02, or roughly this area here. Now, the whole area under the curve, all of the area, if I was to go entirely from negative infinity to infinity, adds up to 100%, or 1. So this value that we're going to get is going to be a number less than 1, because our calculator is going to give it to us as a decimal, not as a percent. More specifically, I know that because this is a normative curve, it's going to be split exactly in half, so that this line right here represents 50% going this way and 50% going that way. So the area under the curve that we are specifically seeing will be less than 50%, or less than 0.5. I know that before I start. If I were to guess, and I haven't calculated this yet, I would guess that this area under the curve is going to be roughly, it'll be less than 0.2. It'll probably be about 0.15, something like that. So now, here's the other part that I don't know. I don't know whether you use z-score tables, which you could use, or whether you use your calculators. I'm going to go under the assumption that you're going to use your calculator, and I'm going to go under the assumption that you're using a calculator like this one, which is a TI-84 or a newer TI-83, which means when I go to use these buttons, you might have slightly different buttons, okay? And so I'll talk about how it'll look if you don't have this style of calculator. You're going to hit the blue second button and then the vars button to get into what's called distor, for distribution. These are all of the buttons for distribution. Most specifically in Math 20-2, you will use only those two ones, either number 2 or number 3. The normal CDF, which will give me the area if I know two values, or the inverse norm, which gives me a value if I know the area. I'm looking for the area under the curve, so I'm going to use number 2, the norm CDF. Now, this is the part right here that might look different for you. You might not get this if you have a different calculator. But these four components are the components that we're going to deal with. Okay? And you'll see what happens when we write it. The lower limit is the limit that we want to look at. In this case, that means it's this limit right here. This is my lower limit. And then similarly, if I look at this, this is my upper limit. Okay, so my lower limit and my upper limit are defined by what was given to me earlier, negative 1.75 and negative 1.02. So when I go into my calculator, it's going to be negative 1.75, and my upper limit is negative 1.02. Now, in this question, it defaults to the Greek letter mu of 0 and the Greek letter sigma of 1. This mu stands for the mean. We already showed you that in this area, when we're talking about z-scores, the mean is 0. That's what this was telling us. Okay? The standard deviation in a z-score is 1. So these values are the defaults if the z-score is 1. If we're dealing with real data, when they give you actual data, they might have a real mean and a real standard deviation. So those numbers won't always be 0 and 1, but they are for right now. Now here, it goes into something called paste. And the reason it goes into something called paste is because you might choose to put this into a calculator to graph it. I don't know if Mrs. Nessick has taught you that or not. It doesn't matter, because in the end, what happens is it pastes this. Now, here's the part that if you have an older style calculator, this is what you start with. You'll start by typing in normal CDF. You'll find that second dister and then go to number 2, and it'll just pop up like this. It won't tell you to use the lower limit, the upper limit, the mean, and the standard deviation. So you would have to type in negative 1.75, comma, negative 1.02, comma, 0, comma, 1. Either way, once you do it, you'll get an answer. And like I said, I remember how I said I thought the answer would be probably around 0.15. I was close. Negative 0.11. So that means negative 0.11 is the answer of the z-score. If what that really means is that about 11% of the population would have a z-score between negative 1.75 and negative 1.02. Without context, that doesn't mean anything. But in certain contexts, when we're talking about marks for a large number of people taking a test, when we're talking about the rate of blood flow for people, or anything involving a large number of people where there's variance in what happens, that's when we could have this. And we would expect about 11% of the population to have a z-score between those two values. And that's what that more or less means.